Hi, welcome to solvinggo.com. In this video I'm going to give another example of using implicit differentiation, and it's used to, in this case, prove a fact which, after some thought, is somewhat intuitive. So we're asked to show that any tangent line at a point P to a circle with center O is perpendicular to the radius OP. Okay, so that's the goal. Let me erase this problem here and give us a picture of what's happening. So let's take O to be the origin. Okay, this shouldn't matter exactly where the center is. So we take a point P. What we need to show is that the tangent at P, okay, so let me label the point. This is point P. The tangent at P, which is this line, is perpendicular to OP, which is this line here, or line segment. Okay, so this is 90 degrees. Okay, so this is point O, the origin. All right, so what we need to do is we need to get an expression for the tangent line at point P. So say this circle has radius r, then the equation of this circle is x squared plus y squared equals r squared. Okay, so the slope of the tangent line at point P is given by the derivative, so y prime. So here the goal is to first find y prime so that we know something about the slope of this line here. Okay, so we're going to use implicit differentiation to do that because here y is defined implicitly in terms of x. All right, taking the derivative of the left-hand side, we get 2x plus 2y times y prime equals 0 because r is a constant. I'm going to erase this picture here. Okay, now we need to solve for y prime. And we get that y prime equals negative 2x over 2y, which is negative x over y. Okay, now we have an expression for y prime. Let me put up the picture again. We have this circle centered at the origin, point P. We chose to visualize it to be this point here. Okay, this is the tangent line at P. And OP connects the origin to point P. Okay, so this is the slope of the line, tangent line, at xy. Okay, so this is a point x and this is a point y. What's the slope of OP? Okay, this line segment. Well, because it's centered at the origin, the slope is rise, which is y, over run, which is x. Okay, so here we have the slope of the tangent line. And here we have the slope of OP. These lines are perpendicular if their slopes are negative reciprocals of each other. What do you get when you take the negative reciprocal of negative x over y? Okay, so here we're getting the negative reciprocal. So that means taking 1 over and taking the negative of that. What we get is negative 1 over negative x over y, which indeed, I'm running out of room here, equals, the negatives cancel, the fraction flips, is y over x. Okay, so we see that we get the slope of the line OP, showing that these two lines are reciprocal. Their slopes are negative reciprocals of each other, so these lines are perpendicular.